Mr. Dr. Wilson Osu, F. NAPI, the immediate past NAPI Warri Chapter Coordinator, and currently a member of the Advisory Council of NAPI. I really want to appreciate each and every one of us to have made our time to be in this meeting. This meeting promises to be a very exciting one, and we are here to look at yet another topical issues. The agenda for the meeting is as shown in the slide. I don't know if you can see my slide. Okay, good. This is the agenda for this meeting. Dr. Ogbe is on call. He will take us through this the safety moment. Then thereafter, I'll come back on behalf of Professor Juliet to take the opening remarks. Then all other programs will flow as shown on this particular slide. Dr. Ogbe. Dr. Ogbe is on this call. Can you hear me, please? Dr. Ogbe. Today, can you upgrade him now to become a panelist? Maybe.
Okay, that's what I'm doing. Okay, Dr. Ogbe, you're welcome.
Okay, can you hear me now? Good morning.
Yes, we can hear you.
Can you just add? I have a screen.
You want to share your screen?
Yeah, I want to share my screen.
Okay, let me stop sharing then.
Hello?
We can't see your screen. We are not seeing your screen.
You're not seeing my screen?
No.
Yeah, not yet.
Are you having difficulties sharing your screen?
Or I should continue like this?
We can't see your screen, so you can continue. I'll just go back to the agenda we had. So please, you can go ahead. If something we can flow.
Okay. Good morning. So let's check on our screen and eye strain. The more time someone spends staring at a screen, the higher the risk of a eye injury. So therefore, we should apply our screen filters. Our screen filters on our system and find a way to reduce the light intensity of the system. If using a mobile phone, we should put on our screen save mode. And sitting properly at our desk when using the computer system. To avoid the back and neck ache, we should keep our back, neck, and head straight and upright with our shoulders up and rest our back against the wall. And after the program, we should try and stretch our body and make some exercise. So I will sum everything up to avoid we should stay out of trouble and stay at peace with our neighbors and our colleagues. Thank you.
Thank you very much, Dr. Uvi, for that safety moment. We'll be able to continue looking at it, and we'll stick to that advice as shared with us this morning. Once again, I want to say a very big welcome to each and every one of us. As a way of giving the opening remarks, we'll just have to ensure that we sit back so we can get the most of this technical meeting. On behalf of Professor Juliet, the coordinator of the Warri chapter, I say a very big welcome to us all. It's a great honor to have these AC members, the NAP Executive Committee, fully represented here and led by the able president, who will actually be giving his speech. So I want to use the opportunity to call on our president, Dr. Abiodun Ogunjobi, F. Nape, to give us his opening speech. My president, sir, I yield the floor for you.
Okay. Good morning, everyone. Distinguished ladies and gentlemen of this noble association, it is my pleasure to welcome everybody to this technical meeting. Our gathering here as members of NAPE signifies not only our collective commitment to advance the knowledge of oil and gas exploration, but also our dedication to ensure sustainable development of the industries. So the challenges that we face today in exploration are complex. Yet they provide us a unique opportunity to push the boundaries in the area of exploration and development. So technical lectures like this is where NAPE brings our best hands together for us to design, foster dialogue, create an atmosphere for interaction where we share our ideas together on how best to advance the exploration and development of oil and gas in the country. So I encourage each and every one of us to be attentive as we go into this topic that will be presented to us by Dr. Nosike today. NAPE, like we always say, we pride ourselves as the knowledge base of the industry. We will continue to create opportunity and platform where we can share ideas together, build network, and actively participate in the development of oil and gas in the industry. So I would like to extend our deepest gratitude and thanks to the Warri chapter on behalf of the executive of NAPE for being consistent in the organization of the technical business meeting. And I want to enjoy each and every one of us to make this meeting an important and exciting one. During the course of question and answers, we can make contribution that we advance excellence in the petroleum exploration. So on that note, I would like to thank everyone who has joined me from far and near, and I use this opportunity to welcome you once again to the Warri chapter technical business meeting. Thank you, and lastly, we look forward to see everyone in November during the annual conference of our great association. Thank you very much, and let us have a wonderful discussion. Thank you.
Thank you, Mr. President, for that huge commendation of the Warri chapter for our consistency, and we'll continue to fly the NAPE flag higher and take it to higher grounds and breaking new frontiers as long as education in the oil and gas industry is concerned. We'll keep doing our utmost best, pursuing the goals and aspirations of NAPI. This morning, to chair this particular technical and business meeting, we have an Amazon in our midst, in the person of Mrs. Ajayi Olajumoke F. Napi, the CEO of Ingencia Energy Limited. This energy Amazon is the CEO of Ingencia Energy Limited, the operator of PPL 202. She holds a bachelor's degree and a master's degree in Master of Science degree in Applied Geophysics from the Federal University of Technology, Akure, and University of Lagos, respectively, and started her career with Mobile Producing Nigeria Unlimited, ExxonMobil. Before joining in Ingencia Energy Limited, Olajumoke worked in Asharami Energy Limited, the upstream arm of Sahara Group, Centrica Resources Nigeria Limited, British Gas, Peak Petroleum Limited, and decollement Consulting. Having successfully exhibited exceptional abilities in the oil and gas industry for over 2 decades, Olajumoke rose through the ranks to become one of the first female managing directors in the upstream sector in Africa, a remarkable feat that makes her one of the foremost practitioners in Africa's oil and gas sector. She has a vision to effectively transmit her knowledge as a foremost geoscientist with far-reaching regional and global influence on oil and gas-related sub-terrestrial activities by mentoring young professionals. Olajumoke is a member of American Association of Petroleum Geologists, AAPG, Society of Exploration Geophysicists, SEG, and the Nigerian Association of Petroleum Explorationists, NAPI. She is blessed with a supportive and understanding family. This upstream Amazon is an icon in the sector and is sure to remain an inspiration to potential oil and gas experts, oil and gas sector experts. Ladies and gentlemen, please permit me to welcome Mrs. Olajumoke as the chairperson of this NAPI Warri Technical and Business Meeting for August 2024. Madam Chairperson, sir, the floor is yours to coordinate these affairs from this moment henceforth as you start by giving your opening remarks. Thank you very much, ma'am. Hello, ma. Can you hear me?
You are muted, ma.
Good morning, everyone. Thank you very much, Doctor. Good morning, my president, my PE, and everyone on this call. This meeting, from what I heard, will have to be ended by before 1 o'clock because NAPI has some other things that they will use this platform for. So we'll make it as fast as possible while we all enjoy the session and share knowledge and have some takeaway from this meeting. The topic for today, like we all know, is the role of tectono-sedimentary activities on hydrocarbon trapping and retention from onshore to shallow and deep offshore Niger Delta. As we all know, the tectono-sedimentary activities combines the effect of tectonic movement and sedimentary process, over geological time. And we know that as we transit from onshore to shallow and deep offshore terrain of the Niger Delta, the dynamic of hydrocarbon trapping and retention becomes more complex. So this topic today will be an eye-opener for many of us, and it will help us to have a very good understanding of what is happening in the subsurface before we venture into putting millions of dollars into drilling. And our ability to accurately map and predict this subsurface activity or structures will be key to ensuring that we have sustainable and efficient extraction of oil and gas resources. So I want us all to, and request us all to sit attentively to learn from the guru of tectonics himself, that's Dr. Livinus Nosike, as he comes in. But before he comes in, I want us to listen to his profile, and that will help us to better appreciate the speaker of today, and it will also help us to believe that it's really the right person to do justice to this topic. Dr. Livinus Nosike holds a Bachelor of Science degree in Geology from the University of Nigeria, Nsukka. His master's degree in Petroleum Engineering and Reservoir Geophysics from the University of Pearl and Pace Dolo, and a PhD in Science from the PhD in Sciences of the Universe, Tectonics and Petroleum Geology from the University of Nice, Sophia, Antipoli, France. He worked with Total Energies at Vegas Scientific and Technical Center in France, and in field operations with experiences in the UK, Norway, North Sea, and in East Africa. On returning to Nigeria, Dr. Nosike founded the iES Oil and Gas and Elvee Energy Training to provide interested young geoscientists and engineers with training and career opportunities in the energy sector. These include digital geoscience and the applications of AI, ML, and automation in the E&P. He's currently the Managing Director of Integrated Elvee Services Limited. Dr. Nosike has published many papers on the relationship between tectonics and hydrocarbon retention or leakages in the Niger Delta basin. His collaboration with PTDF has resulted in the publication of his recent work in the PDT journal. The work emphasizes the significance of the K-Pidge's boundary and the role of a post-Santonia crestal projection on petroleum trapping structures from the formations in the Niger Delta to the inland Cretaceous basins. This has provided some of the most relevant forecasts and explanation on the recent gas flare and oil seeps along the line of Enugu axis in the Anambra Basin. His latest technical book is titled Exploration and Production Geoscience, Comprehensive Skills Acquisition for an Evolving Industry. The book puts together what industry professionals need to know, covering the full petroleum value chain from exploration through appraisal to development and production in one volume. This is Dr. Nosike. Like I said earlier on, from his profile, you will agree with me that he's actually the right person to do justice to the topic of today. So I want us to all to sit back and listen to him, because I believe that at the end of this delivery today, we'll have gained a lot. And if you have questions to ask, we'll also note it down. So join me as I invite Dr. Livinus Nosike to take us through the topic of today. Thank you.
Good day, everyone. First of all, I want to thank the organizers of this program. I want to thank the president of NAPE. I want to thank the chairperson and the leadership of the Warri chapter for giving us this opportunity to look into this very important topic, I believe, in the sense that it summarizes what's going on in the Niger Delta, both from the tectonic aspects, so from the structural geology, and from the sedimentology. So I believe it's going to be a soft ride as we look at the full story. I'm going to share my screen now, and then I'll start the presentation. So I'm just giving 30 seconds to be sure you can see my screen. Okay, I believe you can see my screen and hear me clearly. Can one of the panelists just say go ahead, just so we can be sure? Just a confirmation that you can hear me.
Yes, I can hear you. I can hear you
ahead.
clearly. Please go ahead.
Very good, thank you. So the topic has been mentioned, the role of tectono-sedimentary activities on hydrocarbon trapping and retention. We're looking at it from onshore to shallow offshore, and then all the way to the deep offshore, Niger Delta. So we'll start by looking at what we have. We look at the data that is available, and then we look at the Cretaceous basin that is underlying the Niger Delta. We look at the depositional environment, and then we start to look at the structural deformation, the full story. We're going to look at different regions and sections all the way from onshore or from offshore all the way to onshore Niger Delta. And then we look at the stratigraphy, the implication of the transition from the Cretaceous to the Cenozoic. And then we look at some few examples of trapping across the shelf and elsewhere. And then we synthesize and look at the conclusion. So for this work, we had 2D and 3D seismic data. We had ample well data, onshore and offshore. We had gravimetric maps. We had structural profiles and models. We did laboratory measurements of permeability, porosity, density. We built several pore pressure profiles, which is available in all the fields in the Niger Delta. And then we had samples too. We had a collaborative work where we sampled expulsion, leakages on the seafloor of the Niger Delta. And then we look at whether they are thermogenic, biogenic gases, where are they coming from. And with this, we were able to assemble these seismic images. Although it was a 3D overview, here we'll be showing a 2D seismic section, and all the way from offshore to onshore, calibrated with age markers, integrating several stratigraphic elements to be able to tie these sequences across the regions we are interested in. And from this, we had an interpretation of scaled it and looked at ancient margins, reservoirs, compartmentalization, and provided a kind of summary to have a deeper understanding of what's going on in the Niger Delta. So starting from the data we have, as you can all see, there's ample data in the Niger Delta, several 2D lines, several 3D lines, and of course, the NNPC has all this data. So why I'm emphasizing this is it's good to know that for every single well drilled, every single seismic section, there's a repository. This is sent, a copy is with our government, a copy is with our NNPC Limited. Let me not say government now because it's now a company. And so NUIPS and NUPRI can provide us with ample data. Some of these have been published, some were released with authorization, but despite this, we were still limited. So what we did is to take just a single line, okay, from northeast to south, southwest. Okay, that's the main section we took. And I'm showing us that we have other lines. So what we did is to interpret this single line, we project information from this line all the way to this single line. So we can have a full picture of the context we are trying to develop. So I suggest this day that we look at the Niger Delta a bit deeper. Of course, where we are drilling, when we drill 3,000 meters, 4,000 meters, that's the deepest we can go, maximum 5,000 meters. And in the very deep section of the Niger Delta, you are still within the Cenozoic, what we call tertiary. And so we don't look beyond. In any case, if you want to drill deeper, it's very hot. You are reaching the detachment. So you don't see the Cretaceous unit underlying the Niger Delta. We focus on Benin, Abada, and Akata formation. So, but what we did in this study was to go deeper, and I'll show you how we did that. And for you to understand that context, you need to go back to the origin of the Niger Delta, okay, which is in the Gulf of Guinea. And the Gulf of Guinea, which is this Gulf here, was created during the separation of South America to the southwest and North and Africa to the northeast. And so we had the mid-oceanic regions. And then we had this chain and charcoal zone coming from the triple junction. Okay, we had this happened in the middle Mesozoic. So this is the triple junction. This is the Atlantic Ocean somewhere here. Okay, somewhere here. But here we had this incursion into land, the third arm, which came into the continent to form the Niger Delta basin, extending all the way to the Benue Trough and other rift-produced basins in inland. Now, these fracture zones you can see, chain and charcoal fracture zone, we have the Romanche and the Fernanda Po near the Cameroonian mountain. They cut into land, and suffice it to say, as we will display today, they keep affecting the Niger Delta. This happened in the Cretaceous, okay, Mesozoic, then Cretaceous above, and then it created a differential height, so some high that made sediment to now start flowing down deep, which formed the delta. So with this knowledge, if we move just a step down, you will see that the Niger Delta itself, which is positioned here, is actually fed by sediment from the inland, Anambra Basin and the rest. Okay, and why was these basins high enough to create accommodation space down deep? Is because there was a shortening phase that led to, a shortening phase, making the African plate to move northward towards the European plate, and that lateral ramp here created an uplift here. Those uplift created a basin. This is the uplift we call Abakaliki anticlinorium. And this anticlinorium is actually Cretaceous because the uplift is exposed to the eroded. So we collect samples from here. And then there's the Anambra Basin just down there. And from the Anambra Basin, which is this cross-section, you are sending sediment down to the Niger Delta. So the question many of us will ask today is, do we have a continuous bed? Is it not too far, several kilometers? Do we have a continuous bed taking sediment all the way from inland down to the Niger Delta to form the lobes, we know, the incision valleys, the turbidites, and all we are familiar with? That's the question we are going to answer today, and we're going to answer it using well data and seismic. Of course, if you just look at present-day drainage channels, present-day basin fields, present-day hydrographic channels, you can clearly see that the Niger Delta is, this is Onitsha. Onitsha is in the Anambra Basin, so it's coming all the way from here. We can still see it happening today. So in our exegesis, we are going to look at some shallow sediment in present-day seabed and see if they are still going all the way to the Niger Delta. And we look at paleo channels historically. Are they going down to the Niger Delta? This may not be the same sediment. They may have been reworked. They may be synchronous or diachronous. The aim is not to say it's the same sediment, but is there a stratigraphic package we can trace all along? So we'll start by looking at the structure. This structure is from gravimetry. You can clearly see the lobes we are familiar with. There are two lobes in the Niger Delta. And suffice to say that these lobes are controlled by the regional fracture zones I mentioned. This is the chain fracture zone. This is the charcoal fracture zone. You can see that wherever the fracture zone cuts, there's a kind of flexure serving as a wedge and forming these lobes. The Cameroonian mountain on this axis is blocking the flow, creating lobes, this lobal frontal structural profile, also controlling the sediment deposition. And then here you have lateral ramps, you have sigmoidal faults, which are signs of relay. And when you have the end of propagation of this structural lobe or truss sheet, it starts to form a wedge, and you begin to have compression in the distal part of the Niger Delta, which we all know, the toe thrust. So it shows that this structure, these deep structures, chain and charcoal, that happened in the Cretaceous are still controlling our sediment today, post-deposition, even post-tectonic. And these wedges we see occur more in the deep offshore Niger Delta. These are thrust faults, okay, with crestal collapse. Here we have the shallow offshore, which most of us know, the depot belts. We are going to look at them. And then as you go further here, you have the onshore Niger Delta. So this is, I'm just going to show us a bit of that. So I class it as ABC. This is the deep offshore Niger Delta. This is the shallow Niger Delta. Here we are around the shelf margin. You can see the shelf margin, where we're going to have clinoform, top labs, down labs. And then you have the onshore Niger Delta here. I added a bit by giving a D and C in the inland Cretaceous basins, so you can see what is happening in the transition and understand the structural activities in the Niger Delta. Looking at it from the stratigraphic axis, we have three major tectono-sedimentary events. You have this first one, this second one, this third one. Each of these events is prompted by a kind of progression during a regressive sequence. So for us to have a low stand system tract, it means that the sea level went down, and so sediment started to flow inland to come and build all these channels. And you can see each of these low stand is an indication of a tectonic activity. It means there's an uplift or relaxation to create a slope to bring in these sediments. The first low stand system tract, or the first tectono-eustatic element, is clear, because we know that that was the uplift in the Anambra Basin. That was the uplift in the Cretaceous. So that is clear. But we know that following that uplift, there was no longer any uplift. Okay, we don't have any major tectonics happening in the tertiary. But locally, we have events. And I'm going to show you how the sliding of these faults, that is not necessarily a regional tectonic activity, it's just fault movement, creates relaxation and uplift, creating sediment flow. And so this is, we've colored it. You can see this one is a sequence. This is an activity. This is another activity. This one is just post this slope, you can see. So the uplift in the Cretaceous. Let's zoom out so we can have a bigger picture of the story we're trying to build. So I go to the next page, and that takes us to the tectonic activity. Let's now zoom into this deformation gravity tectonics that I am trying to emphasize. Now, if you look at the deformation, most of us are familiar with the extension zone in the Niger Delta, the transition zone as we call it, and then the compressive. As I said, most wells, as you can see, have not even gone, most of these wells have not even gone halfway of, so most of these wells have not even gone halfway of the Niger Delta package, not to talk of reaching this decollement layer. And so here we are familiar with the thrust faults here, the extension here, but just below, if you are able to have a deeper seismic image, what you discover is that we actually have normal faults underlying these thrust faults. For you to have normal faults here, that means you have a tectonic inversion. You have rifting occurring in the Cretaceous, and above here you have thrust, which is another activity in the tertiary. This alone is able to help us identify our KT boundary, our Cretaceous tertiary boundary, or what we call Cretaceous Paleogene boundary in recent terms. If we can identify this boundary and we are certain that we have the Cretaceous below, we can, this Cretaceous is exposed in the Anambra Basin. We can then go all the way to continent and see what is happening. But even before you do that, if you look just deeper, you begin to see some arcing. We call this arcing because these are Cretaceous volcano or magmatism, which we have good records of. And when these arcs occur, they bring in igneous formation that are harder than the sediments beside it. This hardening creates differential load, which means that the sediments that were being buried here will have a slight slope and will slide. That explains the routing of this fault. You see that the normal faults will be routed just before this arc, while the reverse fault will begin to thrust just before this arc. So you see that the Cretaceous sediment is controlling, and what is even important that shows is that some of these emplacements are occurring in the regional lineaments. That's the chain and charcoal fracture zones, okay, or Fernanda Po. They are actually happening in those lineaments, which are weak zones for this emplacement of volcano, meaning that the Cretaceous actively controls the tectonics of the Niger Delta. So that brings us back to our first story, which we are now going to divide into sections and look at them one after the other. So we are familiar with A, B, C, or 1, 2, 3, and then we go to 4, those swamps in the Niger Delta, all the way to 5, which is the inland. We now begin to look at the Cretaceous uplift further here, somewhere at this extreme. I'm going to show us. So you see the slope from the Cretaceous coming down into the oceanic cross, all the way to the continental cross. This is the chain and charcoal fracture zone, because if you trace them from here, as you come, they are going to intersect these our lines that were projected to our major line, meaning that those charcoal, this is the charcoal, okay, and then they are still the ones controlling this deep buried arc. So what we did was to follow this transition, okay, all the way to inland to see where the Cretaceous are cropped and the Niger Delta is lying above it, or what we call tertiary, because in that case we don't call it the Niger Delta. There's a recent publication on it last year, and some of the forecast in that prediction just came to pass when we had gas sieves in those exposures inland. So let's go one after the other. This is the deepest part. So just to bring us to context again, this is the deep offshore, deepest offshore, distal zone, abyssal zone. Then we'll come back to the shelf area. Then we go to the normal shallow offshore. Then we go to onshore Niger Delta. And then we go to the Niger Delta sediments, which we may not call Niger Delta again because the wells they are targeting the Anambra Basin. So we're going to put all this in context. So let's start from one, which is the deepest offshore Niger Delta. Here, you see we're in the abyssal zone, the very flat zone. And then we have this toe of the thrust. And as you go towards this side, here, you already begin to see this is some impact of magmatism, very minor here along the basement. But if you were to come, we have a lot of things happening here. I won't go into detail. This is where we are. This is the last wedge, and then you have the abyssal zone. Okay, you have the eastern and western lobes, and these have all been published in several of my publications. You'll see this, and then the wedges that are creating these lobes. We've been able to get them, the strike slip here, and all that. So there's not much to emphasize here. But as we come inward, you are going to see that those thrust faults we are saying, we have imaged them. We collected samples from this in a collaborative work done then with Ifumel in France. I was opportune to be involved in that interpretation. Samples that were collected here show that the gases and liquids were thermogenic gas. They were wet gas. And so we know they were coming from the reservoir. This is just a section in the very deepest part of the offshore. These are those sigmoidal faults. And we had this crest. And we try to interpret what happened there. I'll just give us a clue and we move on to the major topic of the day. So we discovered that these thrusts are leaking not only from the faults, but also at the crest of the anticlines when the topsil failure limit is reached. And when that leakages happen, it will relax again. Then pore pressure will start building in the syncline. And then you have minor seepages along the faults, but high pressure building in the anticline. So it was an interplay of topsil leakage in the lithology and off-fault leakage. So these leakages we discover happen intermittently. And we discovered they actually happen during tectonic episodes. Okay, so it was episodes of tectonic happening in the tertiary that was creating them. This is quite detailed. I don't want you to pick up everything, but just to show you an example of 4 episodes of mud volcano, which was happening when sediments were horizontal. That is, there was no active tectonic, no regional tectonics occurring, but we had these major leakages, which I just captured in these smaller sediments here, in these smaller units here. 4 episodes of tectonic happening when the units were horizontal. Okay, meaning there was no folding, but just build up of pressure due to local fault movement to create these episodes of leakages. So this gave us some insights on how leakages are occurring in the offshore, again related to fault movement anchored on the Cretaceous. That's the message. And when these sediments fill, they displace, lead to leakages along the fault. When they are not displacing, the fault seal and then build pressure and break the top seal of the anticline to leak this heavy mud volcano that I just showed us here, this mud volcanoes that has been interpreted on seismic. The other things I will have shown us, but no time now, these are geomorphology. For example, we find out that when this paleo channel is deviating, it's because there was an uplift here. Okay, so that brings us to the shallower part of the Niger Delta, the shelf. In the shelf margin, we were able to trace all the top laps and down lap, and we were able to find the high stand, low stand, know all the sequence tracks, and correlated them all the way from onshore. This, you can see the shelf margin here, all the way to the deep offshore channels. I'm going to come back to that. And that's what's happening here with a lot of clinoform occurring not just in present day, but paleoclinoforms at slopes. Okay, and let me emphasize that even in this place, you can see those arcs and magmatic intrusion that occurred in the Cretaceous. So we keep tracing this, but before that, I just lay emphasis on what I showed us now. This is the Nigerian map. This is the shelf in yellow. You see sediments collect here from these channels, and they are doing present-day incision, going all the way from this continent all the way to the Niger Delta, showing that there's a continuous relationship between the onshore and the Niger. We correlated between what's happening here at the shelf and what is happening in the deeper or distal part of the Niger Delta. Again, because of time, we cannot break this. This is sediment collection point at the shelf. When they come inland, they are reworked here and then sent back here. In fact, we can even tell you that when there's uplift, these channels will thin up, and when they go past the uplift, they will, widen. These are geomorphological. We could trace them in seismic. You can see widening channel here because there's no uplift. Deep incision because it's cutting through an uplift. So this helps us to even time the tectonics, so that some of the things we are looking here is from a wider scope. This is a correlation between the shelf margin sediments and what's happening in the deeper offshore further in present day. Okay, we can correlate all the sediments, okay, as you can see here. Okay, somebody is raising hand to ask a question, but I think question will come later, except you are informing me of time. Okay, if you are informing me of time, I'll say I'm conscious of it. I think we'll spend like okay, yes, we have spent most 18 to 20 minutes. So let me go on. So now this is, as we now come, we know the upper Miocene depot beds, the Oligocene and so on. You see, we begin to see the charcoal fault area, which caused this major arc. Do you see that the faults avoid this arc, routing just beside it? Okay, so this clearly shows that the rifting phase is affecting present-day Niger Delta. One other thing we did before I start to summarize is that if you trace this zone all the way to continent and see where it outcrops, which takes us to the last part of our story, where it outcrops, you see that this KT boundary outcrops on the surface. So we can do field work. We can look at what is happening in that Cretaceous and link it to all this story I'm telling about expulsion, trapping, and all that. Okay, so that brings us to the last part, which is this trapping. Okay, now we already know the sequences, the styles in the Niger Delta. So I try to do something a bit away so that we can still be talking of something relevant. The first one I want to give is an example that in the shelf, this clinoform that comes to deposit during low stand, it will come and deposit sediment down deep. During high stand, the sea level will rise and it will give you a top lap. So all these top lap and down laps, okay, which I explained the formation here, we notice that we still have them further away from the shelf. So you have these paleo shelves here. So anywhere you have a dynamic slope, that is, you have a subsiding basin and there's a deposition at a slope similar to this area, especially with the presence of fault, you form similar clinoforms. And we're able to start identifying some of them inland. Okay, meaning that all we had is a migration of the delta. We had a migration of the delta from inland further offshore. And so we were able to size this. We have up to 150 meters, several kilometer length, height, deep, and all that. We check this. And this is occurring. We see this away from the deltas. And several wells have targeted this as channels. Some people target them as channels. But yes, because there's a slope, there are channels along these incised valleys. And so this is the sequence which we are familiar with. This is it. This is a sequence stratigraphic bundle with all the HAC and all that we correlated. Okay. Now, we were able to see this from analogs elsewhere. This is suburb Delta in Spain. We took some analogs there. And even onshore, you can see some of these things exposed in present inland basin elsewhere. In those areas, like the Spanish basin that we looked at then, it's foreland basins. These are foreland basins that are created. The heights were created by foreland basins, by the Eurasian plate colliding and all that. Here it is different. Here is an uplift of the Cretaceous Anambra basins and around the Enugu axis that is creating the slope on which that drives sediment down to the Niger Delta. So you see a similarity. So we follow this and continue tracing this sediment all the way inland. And this Imo shell today is actually our KT boundary. Funny enough, this then is Niger Delta. Okay, if we are to properly interpret, this is tertiary sediment. The wells drilled here are not targeting the shallow tertiary sediment. It's actually targeting the Anambra Basin. So we call them Anambra Basin wells and all that. But the shallow sediments are actually the same packages that go down to the sea to form all those Akata formation. And it's thicker right there. Here along the Anambra Basin, you can see it is also shallow here, and the KT boundary is exposed. There's a current study I'm promoting. People have gone to take sample. We are looking for iridium. We are looking for all the evidences of this KT boundary, because just across this KT boundary, we begin to see uplift. We have present day volcano, not present day, but what we have is a situation where the volcanoes are exposed. We have igneous rock, and we can see all this Cretaceous activity that we trace deep in the Niger Delta to explain our fault routing, to explain our slope that is creating the channeling, the fault routing, and finally the clinoform and structures that form the sediment. So this is a kind of summary, okay? A kind of summary. We have faults and all that. We are not going to go into that detail. But let me just give you an example of application, okay, in this outcropping area. Because in the Niger Delta, we have a lot of seepages, we sampled and all that. And they are happening at the crest of anticlines, as I've shown us. And here in the tip at the Enugu axis, even before the recent leakages we found, we had already showed that the Cenozoic sediment or the Niger Delta packages that continued at this KT boundary will result in pressure, dynamic transfer of pressure to this crest. And this crest becomes the weakest point that if you create any drilling or any weakness, is going to lead to leakages. After this, we've seen two more leakages in this zone. One was a gas flare that we presented in Nape. I presented that paper 2 years ago in Nape, 2002, and explained that we will have more leakages along the Nike line based on this knowledge. And just last year, we had another incident, and we have wells that are seeping. A lot of activities here, which has become a major prospect now, at the boundary between the Niger Delta and the Anambra Basin, a line we call the Enugu axis. So this is a kind of summary to show us other things that are happening that is related to Niger Delta. So in summary, there's a genetic inheritance of the Niger Delta from the Cretaceous basins. We need to look at these basins together. We have to know that they are related. The inversion, the tectonic inversion, the decollement layer, the detachment, the depositional structures, the clinoform are all related between the Cretaceous and the shallow Niger Delta, what I now call shallow. Not really shallow. I'm talking of your Akata, Agbada, and Benin formation, everything put together. And the geomorphological indicators of these basin fields, okay, can be used to predict our reservoir architecture, even the compartmentalization, when they leak, when they trap, when they get to topsoil limits, timing of the tectonics, timing of the overpressure, which are done in a larger scope work. Okay, it is the differential burial that happened due to the uplift inland in the Cretaceous basin that result in this differential burial that transmit the sediment to the Niger Delta, creating all these anticlines and slopes where the faults are transmitted and they leak when they reach the limiting stress. In summary, conclusion, the whole story of the Niger Delta can be summarized in three activities. The Cretaceous rifting that happened in the Mesozoic continued until late Cretaceous in the Abshan that created the uplift, the high, the quest that we see today in the Enugu axis and all the way from Imo Shale that transition into the Ogwashuku formations and all that, or sand of the Niger Delta sediments. And then this slope created fluvial channeling all the way from continental fluvial sediments down to the slopes, clinoforms, shelf margin, both paleo and present day, because in the Enugu axis we still have marine sediments. So these were ancient deltas, okay, or ancient slopes with incursion of marine sediment during transgression with eventual regression. And this slope created the gravity-driven faulting. Of course, we had always known the Niger Delta is gravity faulting, but we have not seen what is leading to these anchors. Why are those faults positioned exactly where they are positioned? Whether listric faults, whether or rotated faults, or the troughs we see further offshore. So the underlying Cretaceous have a similar genetic relationship with the Niger Delta. The missing link is actually the Cretaceous tectonics, okay, the volcanic orogenesis that build that create hardening, local hardening, on which the faults are rooted, and on which marine and continental sediment will now build across this fault. The fault compartmentalize them. You have shale, you have sandstone, creating reservoir seed pair that have created some of the wonderful reservoirs we've been tapping, okay, that now course across the KPT boundary all the way to inland. So this is the summary of the work. I want to thank you all for your attention, and we're able to present this detail in just a very short time. Thank you once more for your attention.
Thank you very much, Doctor, for this insightful presentation. And I believe that everybody on this call has been taken back to university days. You know, a lot has been learned from this presentation, and I believe many will have questions to ask. I followed your presentation attentively, but I don't know if I captured everything. But let me just give a summary of what our presenter has said before we go into question and answers. You know, he started by letting us know the type of data he used, that 2D, 3D well information, and he took us through the look at Niger Delta and mentioned that you know, we believe we've drilled wells, deep wells to date, but there are still some untapped structures at depth that we need to look at. It took us back to the origin of Niger Delta by looking at the separation of the South American and African plates in the middle Mesozoic history, and it touched on how all our basins are created so that we can all understand, you know, what still needs to be done. He took us through Cretaceous basin, which he discussed in detail. He mentioned that we have 3 major Tectono-Sedimentary events from late Cretaceous to the Nosike, and he mentioned the dominant progression sequence. So the different, most importantly, which parts that talks on the title of the presentation today, he mentioned the different expressions of leakages on our sea floor. You know, most people shy away from going to deep water to explore because of the risk involved and the complexity of the geology around there. So the different expression of leakages on the seafloor, despite the known intermediate seals. So he talked of the top floor leakages through tectonic episode and explained how leakages are occurring in the offshore. He also mentioned the implication of an evolving shelf margin and the impact of Cretaceous events at the paleo margins, near surface impact of Cretaceous tectonic, and prospect location, like he's also said, should be on the closure, especially when you are moving from Niger Delta to Anambra Basin. You know, it should be around the closure where the you observe that the incidences are observed along the naked line. So on his conclusion page, we have that on the screen. So he mentioned that tectono-sedimentary events across the Niger Delta from onshore through the shallow to deep offshore are controlled by Cretaceous rifting, severe channeling, and gravity-driven faulting. So I believe that many of us have put down some questions, and our presenter is ready to answer. But please, question and answer is just for 10 to think about. It's for 20 minutes, 10 to 20 minutes. So let's just go straight to our questions so that our presenter can give you the appropriate response. I have one question here. Dr. Livinus, can you hear me?
Yes, I can hear you.
All right, so let me read out the first question. Thank you so much for the insightful presentation, Doctor. Well done. Is there any link between sea level fluctuation and evolution of antithetic faults in the Niger Delta basin? That's the first question.
Okay. So the answer is okay.
Sorry, Doc. Just
do we put the questions together or just wait to the end?
Doc.
Okay, go ahead. Yes.
Just an information, please. That I've just been told from the secretary that we can use this time till 2 o'clock before the SLP. Yes, so we can have more time to have an interaction.
Okay, thank you very much. The information I was given earlier was that it will be for before 1 p.m. All right, so we have room to ask more questions. So let's go ahead.
Okay.
Let the questions continue coming in. I can only see one question here. Please ask questions, ask questions. You know, the simple part of the Niger Delta, rollover structures, those ones have been explored. We'll still have untapped complex areas. So these are the type of areas where you can tap knowledge that will help us explore deeper and also deal with those complex structures. So please ask questions. All right, to my presenter, you can go ahead to answer the first question. Thank you.
Okay, thank you once more for that question. So the question is whether the antithetic fault, so you are talking of listric faults with synthetic and antithetic faults, is there a relationship between them and sea level rise and fall? So now, a single antithetic and synthetic fault, a single fault or so, is so minute to affect the sea level. So, but globally, you should understand that before, let's look at it this way, look at it that it is actually tectonics that affect sea level. So for sea level to rise or go down, two things can cause it. In the passive margin, like Africa, Nigeria, Gulf of Guinea, where we are, it is only tectonics, it's mainly tectonics. So for sea level to go down, it means that the continent is rising. So look at it that way. So it's like seesaw. If the continent rise, it means that land is going up, the sea is looking lower. In the temperate regions, there's something else that can cause it. That's melting of ice. When the ice melts, even if tectonic was constant, sea level will rise because water is pouring into the sea, so it will rise. But in our area, it is mainly tectonic, it's mainly uplift that causes sea level to go down. And so if there's relaxation in land, sea level will go high. If the land is going down, the sea will look high. So to answer your question, a single listric fault is too minor. But when you consider that the antithetic faults are happening because you are in an extensive zone. So don't look at one, look at the whole thing happening in that region of the Niger Delta. The whole region is in a kind of normal faulting. The normal faulting means there's relaxation. For there to be relaxation, there's a slope. So meaning continent has risen to some extent. So there's a link, but not out of a single one. There's a more bigger link. I hope you understand it. There's a bigger link between normal faulting in general, extension in general, and sea level rise and fall.
Thank you very much. I hope your question has been answered. So that question was asked by Ovie. So the next question is from Tope Adelaja. It says, thanks you so much for Doctor for your excellent presentation. From your work, what can you say are the differences between the western and eastern parts of the Niger Delta basin?
Okay, very good. That one is another very good question. So what decides the western and eastern? If I show this somewhere, these two basins, these two sides, you know, we have two lobes, the western and eastern lobes. They were controlled by the chain and charcoal fault zones or other fault zone or regional lineament. One of them being the Cameroonian mountain on the east. So what means is that as you're having progradation, as sediments are coming down, okay, as sediments were coming, or as you have sediment running down, okay, during regression into the sea, they divided into two because of these fracture zones, and then started to wedge, end of propagation. The difference is that in the eastern part of the Niger Delta, you have an additional constraint, which is those Cameroonian mountain which made the sediment to have a kind of, we have found strike slip there. So what it means is you have, if I'm to illustrate, which I don't mind doing, you have here, you have the Cameroonian mountain as a barrier. You have the eastern lobe, you have the western lobe, maybe Chain-Faco zone here, Charcoal Fault zone here. So you see this sediment now is gliding here. So there's a movement here like this, while there's also an anticline this way. So you are going to have more closures, four-way closures here. And the eastern Niger Delta is much more complex than the western Niger Delta. So I've been opportune to work a lot here. So here you are going to have lateral ramps, meaning on one hand, you have a fold like this, and you have another fold like this. When it works, it creates four-way closure. When it doesn't work, it creates a very complex faulted zone in this area. So the Cameroonian mountain creates more complexity for the eastern Niger Delta. There's a place we call the triangular bulge. That triangular bulge is actually the Cameroonian mountain here, and you have something like this. The triangular bulge is somewhere here. So I don't know if I answer you. That's the major difference. Apart from it, is the same lobe that we have. I don't know if that is clear.
I hope our question has been answered. Please indicate on the chat box if you are okay with the response given to you. So, Doctor, the next question is from Ibrahim Raymond. Says, thank you, Doctor, for the presentation. My question is, if the Niger Delta and the underlying Cretaceous basins have shown similar hydrocarbon generating dynamics, does that also account for the distribution as well, or controls the prolificness of the basins?
Can you take that question again? Sorry. Please just ask again. I was reading the ones.
Okay.
Okay, go ahead. Yes.
My question is, if Niger Delta and the underlying Cretaceous basin have shown similar hydrocarbon generating dynamics, does that also account for the distribution as well, or controls the prolificness of the basin?
Okay. So let's put it this way. You are asking, if they have similar generating dynamics, do we have equal hydrocarbon in each of these basins? Before I go to that answer, let me say that, when we say basin, people look at this from different aspects. When you say Niger Delta Basin, we look at it both from the stratigraphy as well as from the map domain. This is something we must clarify. So let's say, okay, so let's say, look at it. This is the Niger Delta here. This is the Niger Delta Basin. So here is Niger Delta people. So politically, this is Niger Delta. Now, this is the Cretaceous Basin. Let's say it's also running below the Niger Delta. And here you have Anambra people, because these things were named based on people living where it was outcropped on the surface. But be rest assured that this can actually be Anambra State, touching a bit of Niger Delta. Then the one below here may be Cretaceous Basin, but it can outcrop in the Anambra, is a basin here, but it can as well be below the Niger Delta. So that's the first clarification we need to understand. The second thing is the distribution. Now, this is the same Benue Trough, Southern Benue Trough. This is the same rifting that happened in the Mesozoic that created the whole incursion into land. Before the deposition of the Niger Delta, the Cretaceous was probably a delta on its own. That was the first place there was marine incursion, regression, and transgression, as we are now seeing, before this came. So meaning that if we could go back millions of years ago, this would be our present day Niger Delta. But in today's time, this Niger Delta, 1 million, 10 million years, maybe there will be another delta forming above. The difference between the prolific nature and distribution is the age and the event that has happened. The Niger Delta is younger, so it was rapidly deposited, creating fresh sediments and fresh deposits. The Cretaceous has matured more, so even if it were the same prolific nature, you may have more gases here now. The Santonian tectonic had affected a bit of the Cretaceous, meaning some of them were folded and exposed and may have leaked the hydrocarbon. Unlike the Niger Delta that has not suffered any major tectonics, apart from local fault block displacement that creates normal fault and reverse fault. So in terms of retention, Niger Delta has excellent retention capacity. But I can tell you that the Cretaceous will have had the same thing, though most of it now will be gas. And the Cretaceous may be bigger in some areas. So the difference is in the history of these two children. Okay, they have the same parents, the same genetic origin, but these two children have evolved differently, and one is older. With aging, the ability to produce and what you produce changes compared to the Niger Delta. And the Niger Delta finally continues to the deep offshore. So if you call all those things Niger Delta, those the very deep side, then they are more prospect that continues outside the shores of Nigeria. Thank you.
Thank you very much. And I believe the answer is okay, that your question has been well answered. So next question, I think someone's hand is raised here. Chukwemeka Ekwozo. Can you please quickly ask your question? Unmute and ask your question. You are muted, please. Can you please ask your question?
Okay.
All right, go ahead.
Can you hear me? First
Yes.
of all, let me say that what we've heard today is really revolutionary, because all along we've thought about the Niger Delta and the Cretaceous basins as different, non-integrated systems. But I think Dr. Nosike has brought an approach which I think we need to maybe escalate and then or cascade to other parts of our training system. That the Niger Delta basically is a present or a later manifestation of the earlier basins, because from the point of view of the fluids that are produced, the petroleum that is produced, it's quite clear to us that even in the deep waters, in the ultra deep areas, we are probably producing from the Cretaceous. And we found this a long time ago, and then we made some propositions about the generative potential of some Cretaceous, sediments in the Abakaliki Basin. So what he is saying is really great, that we are looking at a situation where the underlying Cretaceous basins are probably feeding the present-day Niger Delta. So we should study all of this as one. We have to look at them, not just the Niger Delta, but go right through down to I would even say, to the Abakaliki Basin. He has stopped at the Anambra Basin, but the Abakaliki Basin is even predating the Anambra Basin. And so in the ultra deep offshore in the Gulf of Guinea, you're probably having situations whereby the Abakaliki Basin, things like the so-called Ezako shale, which we call the Lockpanther shale, are probably contributing the fluids that we're now getting from the Niger Delta. So what I want to say is that his approach is great. He's looking at all this as one integrated system that has been functioning over time. And what we are now concerned with mainly, because it's where we get the fluids, is the Niger Delta. But actually, the Niger Delta probably is producing Cretaceous oils. So thank you, Dr. Nosike, and I think you've done a very good job. Well done.
Thank you so much for that contribution. Indeed, if only you were present in this class, I would say that I had an audience, because the summary of this work is just what you said. The fact that there's a genetic relationship between the Niger Delta and the Cretaceous. So that's the emphasis, and you got it. Just two comments on what you said. Okay. it's hard to produce the Cretaceous directly in terms of well depth in the Niger Delta, because as you move towards the south, so this is the KT boundary, so everything here is the Niger Delta, so everything up here is Cretaceous. I won't call it Niger Delta because this is in Anambra. It depends on how you are looking at it. This is in Anambra area. But as you move towards the south, it deepens. So you get to a point, as I showed during the presentation, where you have a depth of 7,000 for you to reach the KT boundary in the Niger Delta. So wells cannot go there. But yes, you are right. That's what the decollement layer, the heating occurring in the Cretaceous is what's maturing our oil above. Why is it that 3,000 meter depth we have such geothermal gradient that matures our oil? It's because there's a heating system far below that is cooling towards the surface. So there's still a relationship. Now you mentioned a second thing that is good to mention, which is the Abakaliki Basin. Here is it here. That is where you have this Eze formation. This is it. I don't know if you can see it here. Eze formation is here. And the Ogu formation, just the transition before the Enugu shell above. Now, as you said, if you trace this downwards, you will see that's the same unit that continues down into the Niger Delta. The only observation we made is that you have these clinoforms here, or what we can call, you have this system here, similar to what happens in the shelf. Due to this uplift, so you have these packages that here may split into several. That's why as you have one exposure, you enter this another exposure. Whereas in the Niger Delta, they may be more continuous, but it's the same interval of deposition. So it's a bigger work. I'm trying to inspire 2-3 work. Now, one is along the KT boundary. The second one is on sampling the oil we have from the Ezako and the one we have from, say, the Anambra River area, comparing them. Because we have already sampled the one in Ugweme. This is Enugu shell. So we are doing this both from field work, and we've tested this in the laboratory. We have some of the reports. And as I said, there's a paper I published last year with all this summary. So thank you so much for your contribution, because it's the core of this presentation. Thank you.
Thank you, Mr. Chukwemeka Ekwezo. And thank you for the response, Dr. Nosike. So the next question here is from AE. It says, how are basins classified? The fact that there may be Cretaceous sediments in the Niger Delta basin does not make it a different basin. So basically, he wants to know how basins are classified. All right.
Very good. Is this Ehi? Which of the Ehi? Is it Dr. Ehi? Sorry, I'm not seeing the name. Okay, Asweye. Okay. I wanted to know if it's okay, not the FNAP. Thank you so much. So how are basins classified? Very, very important, because there've been a lot of misconception making it difficult to discuss some of these things. Let's start from the concept of what we call the northern, the upper and lower Benue Trough, for example. When people use those terms, it's very confusing, because the upper Benue Trough, okay, lower Benue Trough, the lower is actually southern, not lower. Because when you say lower, we think geologically, you think in terms of stratigraphy. So this is upper Imo shale, this is lower Asia, not in terms of map. The problem with some basin classification in Nigeria is that it was done on a map, which is a bit confusing. So how are basins classified? Let me explain how it is, or how it was done. The Niger, looking at it globally, the Niger Delta, the Anambra Basin, everything is a single mega basin, which should be called Benue Trough, or whatever name you give it. Okay, because if you go back to the history, you had the separation of the Atlantic Ocean, you had the failed and the orogeny that came into land and formed the Benue Trough. That's the major basin. The Benue Trough should be basin of Benue Trough basin. That should be the big basin. Okay, but you can have other sub basins. If what we have, this is the Benue Trough, and this is the Atlantic Ocean somewhere here. So, but in a basin, with time, the basin can be deposited. You can have other basins, like the Abakaliki Basin is the depression here. The Anambra Basin is the one to the west. So within this place, you have this Anambra Basin flowing into the Niger Delta, You have the Afipo Basin or Abekiki Basin here. Another basin were formed here in the north. So the question is, what is a basin? A basin is just the name, the one we used to cook in the house. This is a basin. Any geologic regional area that is this way is a basin. So in a basin, you can have other smaller basins, and that is where we need to understand why we call it different basin. So to bring it to your question, if we have a Cretaceous basin going in this way, below the Niger Delta, you need to understand that if we were to look at it in map, it's going to be this way. If we were to look at it from east to west. So you see, this basin is filled this way. So it's a basin here, but it now extends below, and another basin cuts above it like this. That's the Niger Delta. So I don't know if we can explain it here, but basins are classified because you have a subsidence, you have a syncline, which is filled to form a basin. And so I don't know if this is clear, and it's not what I can explain in a single page. But yes, there's a basin as Anambra Basin because it forms the entire axis, the flanks of a basin. And the Cretaceous, which, to summarize, we should separate between age. Cretaceous is an age. Okay, tertiary is an age. It's not a basin. The Anambra Basin could be Cretaceous. The Niger Delta Basin can be tertiary. That is how to look at it. One last comment. If you want to say the Niger Delta is the whole basin below, you are right. The Cretaceous below the Niger Delta is actually should be part of the Niger Delta. The problem with that is that the Niger Delta stopped. It's not outcrop in the Anambra area. So you cannot go and say that is a Niger Delta basin. While the Cretaceous basin continues. In summary, the Cretaceous basin is a bigger basin that goes beyond the Niger Delta, while the Niger Delta is a smaller basin on its flank. Remember that this Cretaceous basin can continue to the Chad country and Gongola Basin and other basins. So that's the picture we should have. Thank you.
That's good.
Thank you very much. Thank you. So next question. Thank you, Doctor, for the presentation. Would have appreciated for time for your presentation. So would have appreciated more time for your presentation. So you wouldn't have to have rushed through it this way. So
yeah, I was given 30 minutes.
I also agree. It is a paper I'm sure Nape will invite you again and give you like an hour to do justice to it because it's a wonderful paper.
Thank you.
So I agree with this person. Yeah. So I know my president is still on the call and the PE, so they will look into that. So to the best of my knowledge, most of the major discoveries in the offshore Niger Delta have been in the transition portion. And have there been major discoveries in the inner and outer toe thrust regions of Niger Delta? If no, why is this?
Okay, so the answer is that yes, there have been discovery in the inner toe thrust. Okay, there have been discovery, and some wells like the Apple field is we publish 4 papers in the Apple field. Thanks to Total Energies for giving us the approval, the permission to publish those papers. So we publish papers on Apple field, and so Apple field and Egina is in the inner toe thrust. Okay, in the outer toe thrust towards the abyssal, it's not that there are no resources there. Is that they are hard to prospect. That's where it comes all the way to where we call the JDZ, the Joint Development Zone. We've started studies there, but they are more complex to explore. But they've been prospects. There are, I can call 2-3 discoveries. All those deep, very deep water discoveries are actually in the inner toe of the thrust. Okay, and the IOCs have Major Bonga, is it Bonga, or 1 or 2 other fields are there. And then the ones inland, the one in the shallow offshore is mainly we have counted. I don't know if I answered that question.
Please, if your question is well answered, just notify on the chat box so that we are sure you are satisfied with the response. So, Doctor, the next question is from Trust Paul. And it says, thank you very much, Doctor, for your presentation. You briefly wrote about biostract data earlier in your presentation. Is there a way biostratigraphic data could be used to give more insights on tectono-sedimentary activities? If yes, could you give possible ways? Thank you.
Okay, very good. Thank you so much. The first way it could be used is for stratigraphy. Okay, so most of this, let me give you an example. The KT boundary, all the data we have so far was based on biostratigraphy. So there are some organisms we knew lived around the Cretaceous tertiary boundary. And so in Nigeria, there are ample works, and that's all we have now. I just inspired a work now being done by some professors in the university to sample the KT boundary in some areas I showed them, and let's look for iridium, which is a kind of is another indicator of KT boundary. So the first thing it has helped us is the KT boundary, for example. And if you know those KT boundary, you already know where the Cretaceous ended and where the tertiary started. Remember, the last major tectonic episode happened in the Santonian, which is in the Cretaceous. So that already helps you to know where you should expect different kind of features. So that's one way it can help us. Okay. The other ways is that most of what you can see here, the ages of these units were based on biostrat, the ages of these sequences we have here. Okay. And then we also know that when we have high stand, you have higher marine sediment, you have hemipelagic sediment, there are some kind of biostrat data you're expecting. Okay, there are some kind of forums, pores, and all that you will expect. When you have low stand, it's more arid, you have more sand, low water level, and so there's some kind of sediments you will not expect. Okay, eventually we also have shells and all that live in the platform. So there are indirect ways you can use them, but not direct way of linking biostrat to tectonics. It's not direct, but indirectly a lot. Thank you.
Thank you very much. Please, like I said earlier on, just indicate for us to know that you are satisfied with the response given. Yeah. The last question, yes, I am. Thanks for your answer. That's good. So please, just indicate you are satisfied. The next question is from Adeola Adeshida. Thanks for your presentation, Doctor. Please, do you have seismic data or satellite imagery over the area currently experiencing hydrocarbon seeps in Niger line area?
Okay. Very good question, because that is where we stopped. In fact, there's a push we have now to acquire certain kind of seismics in this area, because if we had what we had in the Niger Delta, like in the Niger Delta, as I told you, a major study was initiated, the seafloor was sampled and all that, a lot of bathymetry, a lot of seismics. We don't have such ample data in the Niger Delta, because the Niger Delta, in the inland Anambra Basin, in the Niger line is inland, and so because it's inland, even if we have prospects here, the ease of is even the Niger Delta, which is very close to the sea. We have a lot of issues with operational challenges, environment, conducive environment for operation. So we are still hoping investors will put in more energy in this area. We have very minimal data in this area, but lucky enough, you can see, you don't need satellite to see this, because these are things we've sampled. In the paper I presented in NAPE, I showed the samples, showed the lab results. So these are things you can see physically. But yes, we will need more seismic, more. Some of these blocks may belong to some owners, and these are things we are working on now. And if anyone is interested, please join us. We're actually trying to talk with the regulatory authority to see who owns these blocks, which we may know, and are they still in their custody? Has it been after 5 years of not drilling? Are these blocks available now? There are some things we are discussing now, and we're inviting any interested partner. We had a meeting on this last month with some stakeholders, and we want to shoot seismic, but we need to do it only when the block we have the license, or we partner with those who have the license, and that's just where we are now. We already have a seismic profile we have built for the area. So you know we don't have enough data in that area in terms of, you don't need so much satellite, but seismic is what we need now. We need 2D or 3D seismic in detail in those areas.
All right, thank you, Doctor. And let's move to the next question from Ebimobowe Ofubo. Just a simple question. How do we identify the boundary?
Oh, good. How do we identify the boundary? That's all we did today. So there are about 3 ways. The first one is what I showed you. So you don't need to use one thing. You have to confirm, and that's what we did. So let me show you the first way we did it. The first one is that if you ever have, we know what happened in the Cretaceous, like the magmatism. We know we have rifting, normal fault. So if we ever see such indicators just below the tertiary Niger Delta, it must be the Cretaceous. That's the first way. But we now say, okay, to confirm that, what next do you do? So the first one is tectonic inversion between normal faulting, regional rifting, and any other kind of activity above. The second way we identify it is the impact of the lineaments, like the Charcot chain and Charcot fault zone, which happened in the Cretaceous. What this means is that, okay, what it means is that the chain and Charcot, or all those regional lineaments, they cannot have cropped in the surface today. Because if they are here today, that means they are still active, but they are no more active. They happened in the Mesozoic or late or early Cretaceous. So they are somewhere down here. And when they are here, they become blind. They become blind fracture zones. What do we mean by blind? They are buried. You can no more, they are not active. And then you have this one rooting on top of them. So if you're able to see those chain and Charcot fault zone, like I showed us here, this event, both the magmatism, you know they are the Cretaceous boundary. That's the second way of knowing them. The third way of knowing them is that on land, there are, we have, like I've explained, we have sediments that are deformed. We know those deformations happened in the Cretaceous. So let me just show you that one, very important. That's my summary page. This page now. Sorry. Sorry, just a minute. Thank God we have more time for questions. We have more time for questions. Sorry, let me share that screen. Screen sharing has stopped. Just a minute. Anyway, so while I'm talking, I'll still share that page. Hope you can hear me. Trying to share that page. Okay, I'm going to that page. Okay, so I'll share this screen now. I've shared the screen and it's displaying. So another way to know it is that we know we had deformation in the Cretaceous. So I believe you can see my screen now, and I hope so. Okay, it's about to display. So we had deformation in the Cretaceous. So anywhere in the Cretaceous on the surface where you no longer have deformation. So look at this sediment here. Look at this. Look at this deformation here. So what do we have here? Not just a hiatus. We have a discordance. I hope you can see. So here you see that if we are to go towards the south, this sediment here is not deformed. It's not deformed. They are, if you do what we call isopack, you see they are horizontal, whereas the slope is actually below. So you have deformed sediment and those that are not deformed above. And we know those deformations happened in the Cretaceous. We know the tertiary does not have regional tectonic. So that gives you an idea of a range of area where you have the KT boundary. The final one is final one is that you can use biostract to identify the KT boundary. And then there are some minerals like iridium, which I told you, you can test. This is now to pinpoint the exact band of sediment that occur around it. So I've mentioned 3 to 5 ways to know your KT boundary. So, and let me put it this way. How do you know your tertiary? How do you know your Cretaceous? That's the question. In all those strats we have been using to drill, if you can see where you met your Cretaceous and join the tertiary, that is the boundary. And we identify these things in wells. I don't know if I've answered you.
Are you satisfied with the response? I'm sure he's satisfied because your response is detailed. Please signify if you are okay with, yeah, thank you very much. Yes, he's satisfied.
Thank you.
So the last question here is from Kenechukwu Owuka. It says, thanks very much, Doctor, for a detailed presentation. What will be your suggestion on preventing the gas flares along the Nike line? Also, would you consider the Nike line as a prospect?
Thank you so much. Kenechukwu Owuka is my UK-based trainee. So thank you, Kene, for that question. And so, yes, the first thing is that the first question is, how do we prevent it? We wouldn't have needed to even prevent it, as much as we know there have been some seepages getting near surface. So when we drill borehole, water borehole, we should be careful. That's just it. There should be a regulatory body in Enugu State managing borehole drilling. But that's by the way. The ones that were drilled, that were plugged, and not plugged at the depth of the overpressure may lead to pollutions in the shallow bedding unit. So there was a report we did with details on what to do. You can do a lot of studies to trace these pollutions or those possible pollutions and prevent them. Ideally, we should plug those wells at the depth of overpressure, not on the surface, so that they don't seep to intermediate reservoirs and spread and pollute water. So that's the ideal thing to do. But the second question is more vital. Is it a prospect? The answer is yes. And let me tell you, whenever you have hydrocarbon seepage in present day, is a prospect. Because if you feel it has leaked away, most of these hydrocarbon were generated millions of years ago. So if there was no seal, it would have leaked away long ago. You won't have a trace today. The mere fact that it's still leaking today means there's an efficient seal. I didn't just say seal. There's an efficient seal for it to be trapped today. That is, the seal is breached does not mean it's not efficient. This is another detail. In every oil, the oil you trap is a question of your seal capacity, but there's always some element of leakage. So when you build up pressure, like I've said, the Simpson law is that you leak some, and when your pressure is in equilibrium, it traps the remaining. So we may have leakages today because of breaching, minor faults, leaking. Most of the wells we drilled in the deep offshore, we see pipes, we see chimneys above them, and they are still trapping hydrocarbon. So yes, the Nike line is a major prospect in Enugu, which we already know, okay? And the same reservoir has been drilled elsewhere producing. The one in the Enugu has not been produced, and that's why we are pushing at the moment that we must develop this field, okay? And we are going through the political challenges now to go through the process of ownership and who owns it and who are the investors. That's where we are now. But yes, there's a major prospect there which has already been confirmed. Of course, we'll still do some prospect evaluation, but that's when we have seismic. As you can see, this area without seismic, we had to project this thing based on surface works. Okay, we had to do some projection while waiting to extend this seismic further into northern part of this basin. Thank you so much, Kenny.
Thank you very much, Doctor. There's a takeaway here. When you have a hydrocarbon leakage today, it is a prospect. So when it leaks, it's going to be trapped somewhere else. Thank you very much. I must thank you once, for the excellent presentation. And you are a born teacher because you made it so simple. It is not an easy topic to deliver, but because of the wealth of knowledge you have in this area, you were able to seamlessly break it down and make it simple for everyone to follow. And that's the reason It was an interactive session. Everyone on this call was able to follow. And I've been looking at the number of participants since we started. You know, people have stayed back because it is an interesting presentation. Thank you very much. And we believe that when NAPE calls on you again to make this presentation in maybe at a bigger forum, you will be available to do so. And thank you to everyone who have made it an interactive session. I believe that we have all gained knowledge today. And Doctor, thank you once again. So now I want to hand over to the chapter coordinator. Thank you very much.
Okay, madam, thank you very much for that, for anchoring this part of the meeting. As always, Warri chapter has always been giving incisive topics, and today's own is no different. Thank you for anchoring, and our speaker, we are so indeed very grateful to you to have shared your thoughts, shared your experience, expertise with us. And like what the chairperson said, when you are called for in a bigger forum, you always oblige yourself, you know, to be available to share knowledge. Thank you very, very much. The next item on our agenda is actually going to call on our amiable President-elect, Mr. John Bosco Uche F. Nape. But before he comes on, I just want to acknowledge the presence of our Vice President, Mr. Eyibazwa F. Nape, is on this call. You are welcome, my VP. Mr. John Bosco, our President-elect, please, the floor is yours. Thank you. Okay.
No, many thanks, Dr. Wisno-Sung, the former Warri chapter coordinator. And quite an exciting session listening to Dr. Livinus. And again, many thanks, the session chair, Jumoke Ajayi. So, but before I go into the plug presentation, again, because I'm the president-elect and the host for this, so that I think I also need to then do a few more things before I present the plug. And I think, Dr. Wilson, you already started doing it. But I see on the call, there are other few names is also worth mentioning. Good to see Professor Emeka Ekwozo, who already spoke earlier with the question, FNAPE. I also see Dr. Muyiwa Olawoke, FNAPE on the call. And then also Mr. Alex Taka, FNAPE and the former past president. So just to complete that list, in addition to the ones you mentioned, Wilson, and of course, the president, Jumoke, and yourself also completing that list. So I want to say that first. And then the second thing I also want to say before I do what I'm asked to do, the request by the session chair, Jumoke Ajayi, we're hearing you loud and clear. I'm also sure the president is also hearing you loud and clear. I do believe that this topic will still find its way back into NAPE. I know the continuous education program is already thinking around the frontier basin workshop at some point. So be it this year or be it next year, I think this would have enough airtime to be discussed in that kind of workshop. But we also do know, like the president mentioned, that the NAPE conference is coming. I was going to also put you, Dr. Livinus, on the spot, whether this was already submitted as abstract or not, because this, in my mind, would have been an excellent topic at the conference this year, November. Yeah. But if it's not, we will find a way to catch you back in to still present this at a bigger forum.
Thank you.
Yeah. So, but I think so. Thanks, well done. So let's now go to the job I'm supposed to do right now. So I want to present this virtual plug, and I'm sure you will still receive it in one way or the other through the very active and dynamic current chapter coordinator, Professor Juliet. But at this moment in time, on behalf of the Nigerian Association of Petroleum Explorationists, both the Executive Council and our other councils that we have, the AC and the Board of Trustees, present to you Dr. Livinus Nosike, who is the Managing Director, Integrated Elvee Services Limited, and the speaker for this month's technical and business meeting for Warri chapter, today being the 23rd of August. Now formally present this to you as a word of appreciation for the excellent presentation you've made today and for that knowledge you've impacted to the audience today. So on behalf of the Warri Chapter Executive Committee members, I say thank you very much and well done for what you've done today. Thank you very much, Doc.
Thank you, sir. It's well received. Thank you.
Thank you. And with that, I will hand over back to, I believe, the Public Secretary. And then also appreciation. Well, I don't, it wasn't on the slide here, but I'm not sure who's going to do that. But I also want to, again, especially appreciate the session chair who, as you can see, even in her tight schedule, was able to commit to this. And, you know, it has been quite an exciting session and, you know, chairing it from yourself, also the Q&A. So many thanks, Ejumoke Ajayi, Mrs. for the session chairing today.
Thank you very much.
Thank you. Over to you now, Mr. Lucky.
Announcement. Good afternoon, all, and good afternoon, the guest speaker. We are on announcement. Next slide, please. Monthly technical. Next slide. Written announcement. Next slide. Next slide, please.
Next slide.
Maybe I should do that.
Hello, next slide. Okay. Thank you.
Hold on, sorry.
Okay. Okay, we are on announcements. Okay, next slide. These are the next in our technical series. This is coming from NAPE Benin chapter, NAPE Port Harcourt chapter, which is on 27th August. So we enjoyed all to be part of it. Next slide. This is another presentation from the series too. This is coming from Benin chapter, and the date is Wednesday 28th, which is next week. We enjoy all to be part of this interesting and educative session. Next slide. Yeah, in the series of our presentation too. This is NAPE Warri chapter, and this is our our September technical series. And the topic for the series is application of airborne geophysical field data for hydrocarbon exploration in Niger Delta. We encourage all to be part of this, and this is going to be a physical presentation. So we encourage all to mark our calendars and be part of this interesting presentation. Next slide. Train the trainer, yeah, for making geological maps from processes to product, and the date is 27 to 28 September 2024, 8 a.m. to 4 p.m. daily. and the course fee is 30,000 naira. Next slide. And this is informing us of a 2024 NAPE Annual International Conference and Exhibition. And the date once more is 10th to 14th November 2024 at Eco Hotel. We encourage you just to make it a day with nothing. And the theme of the conference once more is resolve sustainability, sustainable growth, and this is theme for the conference, for this year's conference. Yeah, next slide. And for those of us who have not registered, so we encourage you to be part of it and register and be part of this year's conference. Next slide. Yeah, and this is called for abstract. We have a window, that's an extension for submission deadline, which is on 30th September 2024. Issues, we have an extension and the deadline is 15th. Yeah.
So this is ended. This is ended. This is ended now. So it's just the other process that will follow now from the acceptance.
Okay. All right.
Yep.
Okay, next slide. And this is the conference and floor plan. So, yeah. Next slide. This is the layout for the conference team. Once more, it's resolving the Nigeria energy trilemma, energy security, sustainable growth, and affordability. See you in Lagos. Yeah. Once more, NAPE encourages us to always be updated and to financial up to date, and this is the only way we can benefit more from NAPE. And the payment details for our dues and those who have not registered, and you can equally reach any member of the Executive Council of NAPE Warri for those who have not registered, and those who have registered and are not yet paid their annual dues. The details are placed on the screen. Next slide. Yeah. And we call for opportunities in sponsorship and meeting. 2024 Technical Business Monthly Meeting sponsorship opportunity now exists. Partners with NAPE to host a technical and business meeting in one of the monthly technical meetings and showcase your company technical strength and edge. Leverage the NAPE platform to reach our diverse membership across the world. Next slide. Yeah, NAPE youth and NAPE series of membership. We have the student membership and have the active members and associate membership and corporate membership. The details of payments are there. Next slide. Thank you very much.
Okay, thank you very much, Lucky, the multi of the chapter. We appreciate that. I think we'll just need to on our video so we can just take a group photograph. Tunde, you anchor that, right?
It's okay.
Yeah, so we just put on our videos We'll just take the group photograph before the deputy coordinator will come up and give us the vote of thanks. Can't see the louder than this. Okay, Tunde, are you done?
Not yet. People are still trying to
Okay.
change to video mode.
Okay. Okay.
What I'm working on with what's her name gives us a very good background. I'm gonna pick you there. Okay.
You done?
Okay, let me take it now.
Where is our speaker? And our president?
No, that's true.
They're not here, man.
Speaker,
The speaker is here.
hello. We are all
Your
set.
video. Put on your video.
Just a minute.
Our president too. So please, we are still on call, so we can see you.
Okay, it's done.
The speaker's video must be on. With the president's. President video should be on.
Yeah, I think we've gotten the speaker now. Maybe Tunde, you can go ahead.
Yeah. Okay, it's done.
All right, thank you very much. I believe you're muted, Dr. Wilson. Sure.
Okay, thank you very much, Tunde, for that group photograph. I think we need to call on the the deputy coordinator for the chapter to give a vote of thanks. And that will be it for today. That's Mr. Efe Omojowe. I don't know, did I even see him on this call? Mr. Efe Omojowe. I don't think he's on the call anyway. I'll just take it. He's not on the call. Okay, I want to say a very big thank you to each and every person to have made our time from the beginning of this telecast meeting up until this moment. We are very, very grateful to the leadership of the NAPE executive under Dr. Abiodun Ogunjobi F. NAPE, who led out the cream de la cream of his executive to this place. We thank the Vice President, Mr. Bazwaye F. NAPE. We thank the President-elect, who has contributed in no small measure, Mr. John Bosco Uche F. NAPE. We thank our chairperson, Madam Olajumoke Ajayi F. NAPE, to have made our time to be able to be here. We thank the speaker, Dr. Livinus Nosike, who has shared with us his wealth of knowledge and experience over the years, and we believe that we'll see more of him. Thank you, Mr. Speaker. We thank our own Mr. Alex Nachi Taka, F. NAPE, and one-time president of NAPE. We are grateful to have you in our midst.
Thank you.
We had several persons.
Thank you very much.
That we are on this call as identified by our president-elect. So we thank you. I think I can see Dr. Jackson. Jackson is there. I see the current EIC, Sir Dr. Adekunle Sofolobo, is very, very well there. I can see him. And I thank all other attendees that made our time to be a part of this meeting. And we look forward to having yet another incisive discussion next month. And as we all know, NAPE Warri is a trailblazer and will continue to fly high. We look forward to having you here again, even as we plan to see ourselves physically in Lagos in the forthcoming national, international annual conference and exhibition coming up in November. Thank you very much for all that you have done. I will pray that the good Lord will keep us safe in all ramifications. Thank you.